Satellite multiple accessing implies that more than one user has access to one or more transponders within a satellite's bandwidth allocation. The three most commonly used multiple accessing arrangements are frequency division multiple accessing, time division multiple accessing, and code division multiple accessing. Frequency division multiple accessing is a method of multiple accessing where a given RF bandwidth is divided into smaller frequency bands called subdivisions. FDMA transmissions are separated in the frequency domain and must share the total available transponder bandwidth as well as total transponder power. Time division multiple accessing is the predominant multiple accessing method used today. TDMA is a method of time division multiplexing digitally modulated carriers between participating earth stations within a satellite network using a common satellite transponder. With TDMA, each earth station transmits a short burst of information during a specific time slot within a TDMA frame. Code division multiple accessing is based on the use of modulation technique known as spread spectrum. Users are separated both by frequency and time. Because there are no limitation on bandwidth, CDMA is sometimes referred to as spread spectrum multiple accessing or SSMA. With CDMA, all Earth stations transmit within the same frequency band and for all practical purposes have no limitations on when they may transmit or on which carrier frequency. In both FDMA and TDMA, only one subscriber at a time is assigned to a channel. No other conversation can access this channel until the subscriber's call is finished or until that original call to be handed off to a different channel by the system. Voice data tends to be bursting weakly. So much of the time, no data is being sent over the channel. This inefficiency tends to limit the capacity of the system. The above drawbacks are overcome in this third technique in which the users are spread across both frequency and time in the same channel. This is a hybrid combination of FDMA and TDMA. For example, frequency hopping may be employed to ensure during each successive time slot, the frequency bands assigned to the users are recorded in random manner. An important advantage of CDMA over FDMA and TDMA is that it can provide for secure communication. The GSM network is divided into three major systems: the network switching subsystem, the base station subsystem, and the operation and support system. The basic GSM elements are shown below. Network switching subsystem is responsible for performing call processing and subscriber-related functions. The switching system includes the following functional units: Home Location Register. It is a database used for storage and management of subscriptions. HLR stores permanent data about subscribers, including a subscriber's service profile, location information, and activity status. When an individual buys a subscription from the PCS provider, he or she is registered in the HLR of that operator. Visitor Location Register. It is a database that contains temporary information about subscribers that is needed by the MSC in order to service visiting subscribers. VLR is always integrated with the MSC. When a MS roams into a new MSC area, the VLR connected to the MSC will request data about the mobile station from the HLR. Later, if the mobile station needs to make a call, VLR will be having all the information needed for call setup. Authentication Center. A unit called the AUC provides authentication and encryption parameters that verify the user's identity and ensure the confidentiality of each call. Equipment Identity Register. It is a database that contains information about the identity of mobile equipment that prevents calls from stolen, unauthorized, or defective mobile stations. Base Station Subsystem. All radio-related functions are performed in the BSS, which is also known as Radio Subsystem. It provides and manages radio frequency transmission paths between mobile units and MSC. It consists of many base station controllers and base transceiver stations. Base station controllers. The BSC provides all the control functions and physical links between the MSC and BTS. It is a high-capacity switch that provides functions such as handover, circumconfiguration data, and control of radio frequency, power levels in BTS. A number of BCS are served by an MSC. Base transceiver station. The BTS handles the radio interface to the mobile station. The BTS is the radio equipment, which is transceivers and antennas needed to service in each cell in the network. A group of BTS are controlled by an BCS. Operation and Support System. The Operation and Maintenance Center is connected to all equipment in the switching system and to the BSC. Implementation of OMC is called Operation and Support System. The OSS is the functional entity from which the network operator monitors and controls the system. The purpose of OSS is to offer the customer cost-effective support for centralized, regional, and local operation and maintenance activities that are required for a GSM network. OSS provides a network overview and allows engineers to monitor, diagnose, and troubleshoot every aspect of the GSM network. CDMA traffic channels. CDMA traffic channels consist of a downlink, which is base station to mobile unit channel, and an uplink, which is mobile station to base station channel. The downlink traffic channel consists up to 64 channels, including a broadcast channel used for control and traffic channels used to carry subscriber information. The pilot channel is included in every cell with the purpose of providing a signal for the receiver to use to acquire timing and provide a phase reference for coherent demodulation. It is also used by mobile units to compare signal strengths between base stations to determine when a handoff should be initiated. Station channel uses a Walsh W32 code and same pseudo-random sequence and phase offset as the pilot channel, allowing it to be demodulated by any receiver that can acquire the pilot signal. The paging channels are used to transmit overhead information to the mobile. When a call is being set up, the commands and traffic channel assignment are set on the paging channel. Once a traffic channel is established, the paging channel is ignored by the mobile. Paging channels are optional and can range in numbers between 0 and 7. The downlink traffic channel are grouped into 20 ms frames. The data are first convolutionally coded and then formatted and interleaved to compensate for differences in the actual data rates. The uplink radio channel transmitter consists of access channels and up to 62 uplink traffic channels. The access channel is used by the mobile when not assigned to a traffic channel. The uplink traffic channel operates at a variable data rate mode, and the access channels operate at a fixed 4,800 bps rate. The reverse traffic channel is used when there is a call. Subscriber data on the uplink radio channel transmitter are also grouped into 20 ms frames, convolutionally encoded, block interleaved, modulated by a 64 array orthogonal modulation and spread prior to transmission.